In section 6.3, we start talking about similar polygons, and all of the ratio and proportion stuff we've done so far is going to come up a lot in this section. So explain what similar polygons are and how you know polygons are similar. Similar polygons are two polygons that have corresponding angles that are congruent and corresponding side lengths that are proportional. Okay, the scale factor of two similar polygons is the ratio of the lengths of two corresponding figures. So the scale factor is the ratio of the lengths of the sides of those figures. So in the diagram, triangle ABC is similar to triangle DEF. So this symbol right here in the middle means similar to. So triangle ABC is similar to triangle DEF. So we have to look at the order because order does matter. The A comes first and so does D. That means that angle A is congruent to angle D because they're in the same spot in the order of the writing. Angle B comes second and angle E comes second, so angle B is congruent to angle E. And lastly, angle C and angle F are congruent. Okay, so in similar figures, we said that the corresponding angles are congruent. So A is congruent to D, C is congruent to F, and B is congruent to E. Okay, and that's what it means to be similar. The angles are congruent and the sides are proportional. So check that the ratio of corresponding side lengths are equal. So let's look at the side lengths. We have AB in the small figure. What does AB match up with? Again, if you look up top, AB matches up with DE. They're the first two letters in each triangle. So AB goes over DE. So AB is 10, DE is 15. Okay. The next side we have is BC. BC and EF are the second two letters. So BC matches up with EF. So we get 8 over 12. And then lastly, we have AC. A and C, if you look above, A is first, C is third, and D is first, and F is third. So AC matches up with DF. So we are going to simplify each fraction. So 12 divided by 18, if we simplify that or reduce it, 12 and 18 divided by 6 will give us 2 over 3. For our middle fraction, 8 over 12, we can divide them both by 4. If you divide by 4, we would get, whoops, I can't write. Divide by 4, we would get 2 over 3. 8 divided by 4 is 2. 12 divided by 4 is 3. And lastly, 10 over 15, divide each of those by 5, and we would get 2 over 3. So all of the side lengths are equal because when we set up the proportions and we reduce them, we all got 2/3. So the side lengths are all, not equal, they are all proportional because each fraction was equal to 2/3. And it says, write the ratios of the corresponding side lengths in a statement of proportionality. So what this just means is you set each of the fractions of the side lengths equal to each other. So we would say AB over DE is equal to BC over EF, and that's equal to AC over DF. This is our statement of proportionality, stating that the fractions or the ratios of the side lengths are equal to each other. So you'll be asked this again. You'll be asked to write a statement of proportionality, and that's what this is. Okay, checkpoint. Given triangle PQR is similar to triangle XYZ, list all the pairs of congruent angles and write the ratios of the corresponding side lengths in the statement of proportionality. So let's start with the angles. So angle P will be congruent to angle X because they both come first. Okay. The second letters are Q and Y. So angle Q is congruent to angle Y. And lastly, we would say angle R is congruent to angle Z. So that will be stating all of the pairs of congruent angles. The statement of proportionality would be writing the fractions of the side lengths. So for that, we have to take two letters, such as PQ. PQ matches up with XY. So it'd be PQ over XY equals, look at the next two letters, QR and YZ. So it'd be QR over YZ.
Good afternoon.
Right, and the last two, or last side lengths we're talking about would be R and P and Z and X. So it'd be RP over ZX. And this would be what we call the statement of proportionality. Okay, example 2 is find the scale factor. Okay, so determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. So first, we have to check if all corresponding angles are congruent. So that's step 1. Next, show that corresponding side lengths are proportional. Okay, so let's start with the angles. I see that we have angle A congruent to angle J, angle B and angle K, angle L and angle C, and lastly angle M and angle D. So all of the angles, or all the corresponding angles, are congruent. Now we gotta check that the side lengths are proportional. Okay, so let's look at the two smallest sides. The smallest sides in the one on the left are 8, and the smallest sides in the shape on the right are 14. So we would set up our ratios. We would have 8 over 14, 8 over 14, and 8 over 14. And then we got to look at the biggest side. In this case, the biggest sides are 12 and 21. So we got to check 12 over 21. We have to see, are these all the same? If we reduce 12 over 21, 12 and 21 can both be divided by 3. When we divide by 3, we get 4 over 7. These other fractions, they're all the same. They're all 8 over 14, so we have to reduce them if we can. And in this case, 8 and 14 are all divisible by 4. Oh, sorry, divisible by 2, not 4. Divide by 2, 8 divided by 2 is 4. 14 divided by 2 is 7. So these would all also be 4 over 7 when you reduce them. So all of the side lengths, all the corresponding side lengths are proportional. So lastly, we have to write a statement and identify the scale factor. So the similarity statement is just saying what two shapes are similar. So how I do this is I usually name the first shape. So we can call the first one A, B, C, D. So A to B to C to D. And then we put our similar symbol in the middle. So it's similar to, and what matches up with angle A? Angle A is 90, and so is angle J. So J would come first. What matches up with B? Well, B matches up with K, C matches up with L, and D matches up with M. So it'd be figure ABCD is similar to figure JKLM. And the scale factor is 4 over 7. 4/7. So figure ABCD is 4/7 as big as JKLM. Example 3 in the diagram at the right, triangle BCD is similar to triangle RST. Find the value of x. So first, what matches up with BC? That will be RS. So BC over RS equals CD over ST, again, because CD and ST are corresponding, and that equals BD over RT. So now let's fill in these blanks. So BC is 12, so this would be 12. RS is 24, so it's 12 over 24. CD is 13, and ST is X. So when we fill these in, we end up with a proportion. Do you see we have 12 over 24 equals 13 over X? So once we get a proportion, now we can cross multiply. So if you cross multiply, we get 12 times X equals 13 times 24. So 12X equals 312. So 12X is 312. Now to get X, we just divide by 12. So X equals 26. And again, we got that by setting up our proportion of using corresponding side lengths. Okay, checkpoint. What is the scale factor of LMNP to FGHJ? So to find the scale factor, we just have to find two corresponding sides, write a fraction, and simplify it. So LM matches up with FG. So we would do LM over FG. LM is 12. FG is 15. So when we reduce this, that'll give us a scale factor. These are both divisible by 3. When we divide by 3, we would get 4/5. So 4/5 would be the scale factor. And then if we want to find the value of X, we would use the scale factor, which is 4/5. And we're going to set this equal to another fraction. This fraction has to include X. So X is in the smaller shape. Right? You can see that X is in the smaller shape. That means X will go on the top because 4 is the smaller number, so X has to go with 4. Okay, and what does X match up with? X matches up with 40. So the 40 would go on the bottom. So we cross multiply and get 5 times X equals 4 times 40 is 160. So 5X equals 160, and then we divide by 5. X equals 160 divided by 5, which is 32. All right, and then the perimeters of similar polygons. This just says that if two polygons are similar, when you add up all the sides and get the perimeter, it's going to be equal to the other fractions of the corresponding sides. So if you add up all the sides, it'd be equal to KL over PQ. Zoom in. Which is also equal to LM over QR, which is equal to MN over RS and NK over SP. So these are all equal to each other, the perimeter and then each of the fractions or ratios of the corresponding sides. Okay. So they tell us down here, a larger cement court is being poured for a basketball hoop in place of the smaller one. The new court will be 20 feet wide and 25 feet long. The old court was similar in shape, but only 16 feet wide. Find the scale factor of the new court to the old court. So new over old is how we'll write our ratio. The new court is 20 feet wide and the old court is 16 feet wide. So it will be 20 over 16. So the scale factor would be 20 over 16, which can be reduced. We divide these by 4, and we would get 5 over 4. That's how big the scale factor is for new court to old court. Then it says to find the perimeters of the new court and the old court. So if you want to find the perimeter of the new court is 20 feet wide and 25 feet long. So to find the perimeter, you would simply add them all up. So 20 plus 25 plus 20 plus 25. So the perimeter, I'm going to put P of new court is equal to 90. Because 20 plus 20 is 40, 25 plus 25 is 50, 90 is what we get when we add them all together. So to find the old court perimeter, so we would do new over old. And we said new over old is equal to 5 over 4, right? That was from over here. The new perimeter is 90. The old perimeter we're going to call x. So 5 over 4 equals 90 over x. Again, because it's new over old. And if we cross multiply, we would get 5x equals 4 times 90. So 5x equals 360. And then we divide by 5. So x equals 360 divided by 5 is 72. So the old court had a perimeter of 72 feet. And we found that by using scale factors. Okay, last part. Corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygons. We are going to skip example 5, and we'll just run through the checkpoint. So they tell us that PQR is similar to WXY. Find the perimeter of triangle WXY. So we know that the side lengths are proportional. So what matches up with WX? WX matches up with PQ. So we have 40 over 72 equals, okay, I'm going to call this M. M over 63, right, because this M matches up with the 63. And I'm going to call this one, we'll call it N. N matches up with 81. So we're going to do some cross multiplication to find M and N. So if you cross multiply, we get 72 times M equals 40 times 63. So 72M equals 2,520. And then we divide by 72. So M equals 35. And then we do the same thing now. 40 over 72 equals N over 81. So we get 72N equals 40 times 81. 40 times 81 is 3,240. And then we will divide by 72. N equals 45. So if you want to find the perimeter would be 45 plus 35 plus 40. So the perimeter would be equal to 120 for this triangle. All right. We are also going to skip number 5, and that is all we're going to cover for this section.